Hi everyone, this is my son and welcome to my channel Hassan Academy. So after a long time, but one important concept we are going to discuss today. Okay, so group 17 element, if I am giving you fluorine, chlorine, bromine and iodine. Okay, so and I am asking the hydra acid of group 17 element. Yes, halogen. Okay, what are those? HF, HCl, HBr and HI, hydrogen ion. Okay, out of these four, if I am going to asking you acidity, then you must know that HI is more strong acid than HBr, HCl, HF. Yes, even you don't know, you should understand that everywhere hydrogen is constant. What is changing? Halogen, fluorine, chlorine, bromine, iodine. Once down the group you are going, number of shell increases. Due to that, their size also increases. And what is strong acid? Strong acid which conjugate base is more stable. Once H plus is gone, it will get I minus, it will get Br minus, it will get Cl minus, it will get F minus. Now this iodine is bigger in size, and due to that negative charge can easily stabilize throughout that iodine atom, and it is quite more stable compared to F minus. Okay. Now you have to understand this thing, that once we are talking about acidity, what is the order? Hi is more strong than HBr, then HCl, then HF. Yes, these are inorganic acid, and remember inorganic acid are more strong acid than organic acid. If you in general, if you want to keep the order, inorganic you have to keep first. Okay, their pKa is very minus, like minus 9.5, something like that. Okay, HI, HBr, HCl, HF. Yes, they are strong acid order. Now strong acid produce weak base. So if I get I minus, here I will get Br minus, then Cl minus and F minus. Yes, so if you want to produce, if in general asking what is the basicity order, basicity order will be this one: F minus, Cl minus, Br minus, I minus. So up to here everyone is sure and they are confirmed that yes, strong acid produce weak base. So this is the trend, they are going for it, and mostly they are getting always correct answer. There is no problem. Okay, because now once this is basicity, this is basicity. Okay, up to here acidity this one, basicity this one, up to here. Okay, but once we are going for nucleophilicity, here student getting confused and they are getting sometimes correct answer, sometimes wrong answer, and they are claiming that trend is not going to work here, etc., etc. There is nothing like that. Here you have to understand the concept behind. Okay, so when I am saying I minus, let me draw and explain in details. This is, let's say, iodine. I have taken little bigger in size. Then bromine, I should be little draw smaller. Then chlorine, then fluorine. This one. Okay. Now you have to understand one thing, that everywhere charge is unicharge, one charge. Everywhere one negative charge, but their size is different. So like if you take some let's say some solvent here, everywhere this is iodine, I am drawing this atom, but let's assume it's a amount of water, and this is also amount of water, this is also amount of water. Okay, now everywhere you can drop one drop of ink only. If you drop here only one, add one drop of ink here also, here also, here also, where color would be more dark. Okay, now easily you understand that here, even though everywhere charge is 1, here it is more charge density. You understand what I am trying to mean? Here charge density is more because it is smaller in size, but here will be little bit less, and here will be pale, and here will be, since the amount of ink is equal, here will be very much pale. Okay, this is very dark, then less dark, then it is little bit pale, it is very much pale. Now you have to understand why I am saying all this, because when we are going for basicity, at that time you have to accept only one H plus, accept, or you have to understand this negative charge you have to donate to H plus, then it is called basicity. When this negative charge you will give to any electrophilic center, at that time it will call nucleophilicity. Okay, so everywhere you have give one H plus here. So now you can see that here charge density is more, so it can easily give its electron to H plus, because charge density more, so they will attack each other faster, or you can understand that it can easily give. Okay, so everywhere you understand how acidity coming in point, that this one is stronger acid than this one. Now when we are talking about nucleophilicity, now a lot of things will come, because I already says that this particular rich species of electron, which is we are calling nucleophile here, that nucleophile, when it will go and attack any electrophilic center, then it is called nucleophile. Okay, if it is giving its electron to H plus, then base. If it is giving its electron to particular electrophilic center, then it is nucleophile. Once it is going to attack any particular electrophilic center, at that time so many things is coming in between. Okay, one is solvent effect, that nucleophile you are using with respect to one solvent. Yes, that solvent effect coming again when it is going at that time during the attack to any electrophilic center, that steric hindrance of that particular reactant also coming. Yes, you can say substrate or reactant, particular that position electrophilic center, how much steric hindrance is there, those things also coming. So if your electron rich species is very bulky, it is not easy to show good nucleophilicity. You understand what I mean? Because of its bulkiness in size. Okay, so now you have to understand how solvent effect is very important here and make the completely opposite of this trend. Okay, so let's say nucleophilicity, we are talking about nucleophilicity, and nucleophilicity we will talk in two different solvent. One is polar protic solvent, or you can say water or like that. I will see whether it is recording or not. Yes, absolutely fine. So polar protic solvent, let's say polar protic solvent is water. Polar protic solvent, it can be water, methanol, anything, let's say water or any other polar protic solvent. Now what will happen, since here charge density is more, I already told you that F minus is very much more charge density. Due to that, this water, what will happen, this negative charge water, hydrogen will come everywhere. Okay, hydrogen will come somehow here also, like everywhere, because this is delta minus, so H plus will come and it will make bond, and due to this solvation effect, this F minus is totally surrounded by so many water molecule, it is fully surrounded. Since it is surrounded, due to solvation, now it will become more bigger in size. Before it was smaller in size, but due to now hydrogen bonding solvation effect, now it is surrounded by so many water molecule and it becomes more bulky. One, it becomes more bulky, now its kinetics, now its movement is going to be slow movement. What it is? Slow movement due to bigger or bulky in size movement. Is it was bigger initially? No, it was smaller. But due to, once we are talking about nucleophilicity, solvation effect will come. Now it is surrounded by so many water molecules and now it becomes so much bulky that it is movement becomes slow. Yes, slow movement happen. And since kinetics is become slow, so which one will go faster? This one. This one will be surrounded very less number of water molecule due to charge density less. Here charge density is more, so more water, hydrogen delta plus will come and it will surrounded by more water molecule, so it becomes more bulky, less movement, less kinetics. So kinetics is very important in solvation, nucleophilicity, so it will least in the order. So polar protic solvent I minus is better nucleophile, then Br minus, then Cl minus, at last F minus. Yes, so this is the order in case of nucleophilicity. So whenever they mention polar protic solvent or they have not mentioned anything, just they ask the nucleophilicity order, you have to follow this order. Okay, so now let's go for another point where we are talking about polar aprotic solvent. Polar aprotic solvent. Let's say one polar aprotic solvent is acetone. Yes, propan 2-one. Now here you have to understand this delta minus is here, but delta plus it is not exposed. Delta minus is exposed. It is outside. Delta plus is inside. Since this delta minus is exposed, what it will do? This again you know that this one F minus is smaller, but it is charge density is more. Yes, charge density is more. Since it is charge density is more, so this oxygen delta minus and this, they will do the repulsion, and due to this repulsion, this F minus will movement very faster movement now, fast movement. Okay, kinetics of F minus will increase now. You have to understand what I am trying to mean. I am trying to mean here charge density is more. Since charge density is more and in our solvent only delta minus which is exposed, so this delta minus will come because this delta plus is in between two methyl groups, so it is not easy. Okay, it is outside, so this delta minus will come here and it will try to push this F minus, and it will do more faster movement. Now since it is first movement, now nucleophilicity is changed. Now what is the number one nucleophilicity? F minus is better, then Cl minus, then Br minus, then I minus. Okay, so this is the order now. Hope you understand. So this second point understanding is very important, because this delta minus and this negative charge electron, they will do the repulsion. Due to that repulsion, this F minus movement will faster, and due to that it will show the better nucleophilicity. Hope you understand. Take the screenshot, and this is the order you have to follow. When they are asking basicity, simply go for this order. But when they are asking nucleophilicity, if nothing mentioned or mentioned polar protic solvent like water or methanol, you go for this trend. But if they are mentioned that polar aprotic solvent particularly, you have to understand here trend will be opposite. This order you have to follow. Hope you got it. Thank you for watching, and if you have any doubt, you can write in my email or in comment section. Thank you.